Thank you very much. I appreciate everyone coming here today. I'm going to sum up our talk in about 30 seconds in case you want to run out really, really quickly, which is that ethical human-in-the-loop machine learning is really just human-in-the-loop machine learning. The kind of systems that you want to put in place for humans and machines to interact are the systems which are the most ethical. They're also the ones which will give you the best return for your investment and the highest quality data. So our talk is going to be covering this today. I really appreciated the keynote from Andrew Ng, if you saw it this morning, when he spoke about how you need to start with really, really good data. I believe this was also echoed in the keynote from the VP at LinkedIn. You really need to think about starting your data strategy with your algorithm strategy. Have any of you built machine learning systems and put them in production before? All right, do any of you disagree that you need to start your data strategy early? Okay, good. Okay, so we're on the same page here. We're preaching to the converted. The more respect that you show the people who are doing the human component of data labeling, the better data that you're going to get. And these are 3 points that I'm going to come back to throughout this talk. Safety for the workers, salary for the workers, paying them fairly, security, so paying them regularly, and ownership, providing transparency in the process of creating training data for your machine learning algorithms. So broadly, this is what a human-in-the-loop system might look like. You have a large number of unlabeled data items. You're applying a machine learning model to label those items or to structure them or extract information from them. Active learning is the process of deciding which of those unlabeled data points are the most important ones to put in front of humans for revision. Once you have those human annotations, then that training data can be used to update your model. We'll be covering this last bit down here of transfer learning, so using existing models or data augmentation. But actually, a lot of these same principles still apply. Whether your data is natural or synthetic, if you want human feedback on it, a lot of the same quality controls still apply. So in active learning, what are the principles for good annotation design? There are some basic principles that you can take to almost any use case. So one is, if possible, cast your problems as binary predictions. So if you're doing, for example, a computer vision task with 1,000 different labels, if there is a way to leverage your model so that you can ask someone, hey, is this a picture of a bicycle, yes or no, rather than for them to select among the 1,000 different labels, you're going to get better throughput, better accuracy, and it's going to be a lot easier to do quality control. And this is obviously inherently a human-in-the-loop system because you're using your machine learning model to guide how your interface appears to the annotator. And it's not trivial because you also have to worry about bias, perpetuating only the predictions which were candidates from your model to begin with. Second point, ensure that expected responses are diverse to avoid priming. So for example, if you're having someone do sentiment analysis, and you have 20 things which are negative in a row, negative sentiment, you could prime someone to misread that 21st as negative when it was actually neutral or positive. And so again, this is something that you can do programmatically, is ensuring variety in response. Related to that, if your data is so predictable that you have the same label 20 in a row, then you can think about different interfaces to avoid it being repetitive. So have people label 20 at once and mark the exception. So these are all, again, strategies where you should know what your prediction is to begin with and let that guide your interface designs. Number 3, you should use existing interaction conventions. So if you are having people label on a website, use the kind of forms that you typically find in HTML. If you're having people label on their tablets, use the kind of conventions that people will use to interact with apps on their tablets. If you're having people do something complicated, like full semantic segmentation of images, use the kind of tools that people would find in technologies like Photoshop. You shouldn't be trying to invent new kinds of human-computer interaction technologies when there are existing ones which your annotators can take and be familiar with. This will help with their satisfaction and with quality as well. And finally, while it sounds archaic, wherever possible, allow keyboard-driven inputs. If you're asking anyone to annotate all day and they have to move a mouse a lot, whatever form that mouse takes, it can get very, very complicated very, very quickly and introduce that repetitive stress injuries and, or just general fatigue. And so for a lot of the interfaces you're building, no matter how sophisticated they are, you probably can really easily put in keyboard shortcuts. It's a respectful thing, and again, it's going to create much better data. So I like to think about machine learning in terms of a knowledge quadrant. So what do you know about your model and what do you not know? And also what do you know, and what do you not know? So you can think of your known knowns as your model in its current state, everything that it predicts confidently and accurately. Everything your model gets right and you trust the confidence, there's more than 90% confidence, that's your known knowns. But then everything outside your model's current capabilities when you're trying to adapt it are your unknowns. And so your known unknowns, the things you know you don't know, these are things that your model tells you is low confidence. So if your machine learning model makes a prediction with 20% confidence, this is your machine learning model saying, hey, this is a data point that I'm really not certain about. So this is good evidence that it's something that needs to go in front of a human for review, which will then make your model more accurate as a result. And the school of algorithms to tackle these known unknowns are known as uncertainty sampling. It's a very transparent name. The things your model is uncertain about, you sample them, put them in front of humans for review. The unknown unknowns are a lot more complicated. So this is known as diversity sampling. So these are the methods for which your model doesn't even realize that it doesn't yet know what the response is. And this can be discovered in different ways. So for example, if you have very low activation over all neurons in your model for a given prediction, that will tell you that this is a gap in your model's knowledge. The ultimate prediction might be erroneously very confident, but actually that prediction is made on very little information. There are also a very large number of unsupervised techniques that you can use to ensure that you have data which is very diverse across your data set, which is representative of a target domain that you're trying to adapt to, and also represents diversity in real-world demographics that you might want your model to be equally accurate around. Again, not covering it today, but transfer learning can be thought of as a case of known unknowns. So you have other models which have a lot of interesting latent information which are not yet adapting for your particular model. A great way to use in combination with these techniques to reduce the amount of unnecessary data labeling. Here we're talking about these here, the unknowns, and annotation methods for making sure these items get in front of the right people for review. So like I said, active learning, finding the right data, has two forms. Uncertainty sampling, so the items that are confusing to your current model, and diversity sampling, so items that represent gaps in your current model's knowledge. Both methods are needed to avoid model bias. So once you've decided on the right human-in-the-loop strategy and the right sampling strategy, so you have an idea of what data it is, you need to sample, what your iteration process looks like, then you need to decide, well, who is going to annotate your data? And broadly, you can consider three kinds of workforces. In-house workers, pay per task workers, and outsourced workers. And to go back to our original three points, you can think about three factors for all of them in order to be the most respectful to these workers and to get the best work out of them. So salary, paying fairly, security, paying regularly, and ownership, providing transparency. So I'll go through each of these in turn. So for in-house workers, this is great for expertise that people outside your company might not have. So if you're at a medical imaging company, you might just want trained physicians to annotate your data, for example. And also for security. Same use case for HIPAA compliance. You might not trust any outsourced workforce to look at your medical images. They're also incredibly useful to use to refine with any strategy that you're using. So even if most of your workers are not internal to your company, you still need to be able to provide instructions to the workers. You need to be able to look at the data long enough to decide, is this the right set of labels for my particular problem? And you also need to provide gold examples so that you can do better quality control across the outsourced workers. And this creates one of the most fun things that I've done at any company I've ever been at, which is getting people in a room in your company and just labeling data. So order a pizza or whatever people prefer to eat, get everyone in the room for 2 hours, and everybody sits there with the computers open, labels data on your internal makeshift interface, and then shares notes about when you find an interesting edge case or just a funny piece of text or image that you come across, or discuss any complications that you might have in the label. What I really like about this is it's team building across your departments. So you can sit there and have the data scientists and engineers and people in marketing and people in sales and people in ops all sitting there doing the same data labeling task. So especially if you're in a company where you're trying to introduce machine learning into that company, which is probably most people in this room, and you want to give non-technical people some sensibilities around machine learning, I would start with a labeling task for everyone rather than linear algebra. Like getting people understanding, okay, like computer, you don't have to understand the math, but these machine learning algorithms are learning from these kind of data examples. I think that's the right intuition for a lot of non-technical people to start at. Next workforce, so pay-per-task workers. So I'm sure most of you have used a service like Mechanical Turk, or you're familiar with it, where you can set a price per task and an anonymous person completes this work for you. So here, the salary, security, and ownership are obviously very different to in-house people. Salary should be transparent about the pay that you're given, and most sites enforce this for pay-per-task work. And you should always pay for work. There are some platforms that allow you to not pay if you don't like the quality of the work. Unless you're 100% convinced that something was a robot and not a human, you should always give someone the benefit of the doubt, pay them for their work, and exclude them for future work. You can't possibly know the situations that could lead to someone not providing good work for you. And so the most respectful thing to do is to, maybe pay 99 scammers for every one person that made an honest mistake. That's still the right thing to do. And then if someone's not doing quality work for any reason, just exclude them from that task in the future. Security, so it's tough to provide security in a pay-per-task marketplace, especially when you're abstracted from the identities of the people involved. For the most part, this is amortized by the marketplace itself. Your work may run out, but there's other work on that marketplace. So you get to control that a whole lot. You can a little by being transparent about the volume. So you will attract more workers if you have very large tasks, because people know they can do your task for several hours, not just several items, for example. And so a good way to be transparent is that if you've broken your task up among, say 20 or 30 different tasks on the platform that someone can undertake, or you're now just running a pilot and you'll later want people to run over more data, be transparent about that in your task, and then you'll attract more good workers to your particular job, knowing that there is going to be more similar work later, even if that's not as obvious in the platform itself. Finally, ownership is really important. So give the real world context. If you want someone to do good sentiment analysis, don't just give them the form or positive, negative, or neutral. Tell them the context that this is being used in. So is this going to be used by your marketer? Is this going to be used for spam filtering? And if you're allowed to, if it's not sensitive, tell them the actual company that you're with and how this is going to make life easier for people. Because even a pay-per-task worker can take a lot of pride if they're making a popular in-home device more accurate, or they're making self-driving cars less likely to run over people. So finally, outsourced workers. I don't need to talk about the ways to make these workers more successful myself, because Radar is, I think, the world's leading expert in how to create and manage and get success, especially for enterprise companies that want to leverage workers to create training data. So please join me in welcoming Radar to the stage.
Thanks. Thanks, Robert. That was very nice intro. Thank you. I always like to partner with Robert because he understands well what it means to build a workforce rather than individual workers towards scaling for the enterprise. So it would help to move this Yes. So I'm founder and CEO of iMerit. We're about 6 years old. We have about almost 2,800 people, full-time employees, very professional team of, I would say, a workforce that is really focused on how do you build the partnerships and the results that enterprises need as they go into productionizing AI. So our set of clients are large enterprises, mid-scale, and some startups as well, who are maybe in the early stages of figuring out how data will help them. So we're very focused on the fact that the best algorithm design depends on algorithm training. How many of you agree with that? Algorithm training equals algorithm design. Yes, the design is done by data scientists, but in order to get your best algorithms, you need to have a workforce that is very professional, very skilled, as you go into productionizing AI. So a good analogy is when we think about large IT services companies, you're thinking about programmers, you're thinking about architects, you're thinking about project managers, you're thinking about a whole professional workforce. AI has a set of technologies that need a professional workforce to be able to bring this to complete fruition. I totally understand where we've started, and our people get skilled too and working on mTurk and F8 and people like and platforms like that. But as you really progress forward into going into large-scale production, even within young startups, as you're going to productize your offerings, then you need people who can be with you with low attrition, people who are professional, who are very skilled, and going towards building that kind of a workforce. So we have full-time employees. We have SOC 2 certified, all the ISO and everything. In fact, it was very funny. One of the clients I spoke with, the young AI company in the Valley here, said to me, what is an ISO? What is a 27001? And coming from the long-term IT background, I was like, well, that's where, if you have SOC certification, you can take it from your AWS S3 bucket, the data, and bring it over and actually work with it and not have to worry about building the security around it. And we have 9 centers, soon to be 10, so a very diverse workforce, and less than 5% attrition, 24/7 operations, because we understand that robots can be going around taking pictures of shelves at any point of the day or night, and you have to be able to respond to it with 15-minute SLAs. So these are things that's very important in building the workforce. I would say the case for enterprise partnering, and I use the word enterprise, and that could apply to a large data and AI young company all the way to an established insurance company. It could be in computer vision, so about 70% of our work is in the computer vision area, and 35% is in NLP, content, and text data. So the things that we put together as hearing from clients, and I'll actually share with you a debrief I did with a very large client just this week after they visited us for about 10 days. So importance of consistency and quality. So when we annotate the data, making sure that if there are 400 people working on 7 or 8 different workflows for a particular client, that both across the workflows as well as across the people, there is consistency, there is diversity, because you do want to get diverse inputs into the labeling by the workforce. At the same time, you want consistency. So think about that. Diversity and consistency, often we think about as being mutually opposite, but when you develop a professional workforce, as you would do in the services environment, it's really important to have both of those things. And at the end of it, whether we are doing, and we have a large tech team, which is looking at how can we use ML for ML-assisted annotation, ML-assisted quality, whether we're doing this with ML assistants or we're doing that with our own quality workforce, or the two are working together, that quality, and oftentimes people say, oh, my tool will provide 98% quality, just send me the data. Our clients will say, how do you define that quality? Quality is defined by the client. So we work with the client, with solution architects, to actually define quality. And this would be one of the first things I would say is, as you set out to actually send the data, then please sit with the people that you're sending the data to and define what you mean by quality. What does 98% or 95% or 80% quality really mean? How do you define the edge cases? What is occlusion? Whatever sets of things that you want to look at. Oftentimes, we also find that even with clients, we work about 40% of our clients, we work on their tools. About 30% of the clients, we work on our tools. Like, for example, if you look at AI in medical imaging, there are not a lot of tools out there. There are some. So we develop our own tools. One of the tools we developed was like in panoptic segmentation, in autonomous technologies, because it wasn't out there. A lot of 3D LiDAR tools. So depending upon what's available, we can either develop the own tools or work with, there are custom tools and custom insights into what is happening. And I'll share that with you in a minute. Also, in several cases, domain knowledge and custom skilling, and I will particularly take this for AI in med, AI machine learning in finance. Being able to have some domain expertise, so having solution architects, we have a solution architect who is actually a medical doctor, who is helping us in custom skilling to look at lesions, to be able to annotate images that have a variety of different applications in medical imaging, to train machine algorithms. In finance is another thing, that if you're doing natural language processing and you're working with financial documents, you need some amount of custom skilling, at least domain knowledge, but not, you can do that with a small group of domain knowledge and a large group of people who can do actually the NLP work. Understanding, and this is where very old-fashioned project management comes in, project timelines. What are SLAs? SLAs at 15-minute SLAs. Understanding what those SLAs mean and the judgment around when do you actually break the SLA, when do you not, because that's the right thing for the client, and working with the client on it. I would say the next thing, retain learnings across the iterations. This is probably what clients who are going into the productionizing of AI, or even in the later stages of R&D, find to be the most useful, not just for us as a workforce, but for their own data scientists and guides. So take a client who might have 300-400 people of high merit working with them. They think of a lot of them as a virtual extension of their team. Robert talked about 3 kinds of workforces. A workforce where it's an internal team, but the internal team could be a virtual extension working with a partner. It could be a paper task. We do a lot of work where we're actually, it's a on-demand, volume-based. Or it could be what he called an outsourced workforce, and to us, where you actually get the data and we work on it. But the retail learning across iterations becomes very important. And let me explain a little bit about a learning for me from one of our clients who came in, and I said, why are you spending 9 days with us? It was a little disconcerting to have 3 or 4 members of the client come in and spend 9 to 10 days with us. And they said the best learnings for us come from your team leads, not from the management team who was all ready with the presentations to talk to them. This is one of our largest clients. It wasn't them. They said, yeah, we'll listen to you for half a day. That's fine. I want to know what your CFO is saying. I want to know how you're doing as a company, et cetera. But I want to spend time on the floor with the team leads, not necessarily with just the contributors, not with the project managers and delivery managers, but with the team leads and quality leads. And they watched how the team leads went across. We used to have, our team leads are 1 team lead for 20 contributors, is in general. And they were questioning why they needed so many team leads. When they left, they said, we actually think you should have a team lead and a quality lead for every 15 of your contributors working on our use cases, because the team leads bring that retained learnings across iterations. So every Saturday, for example, team leads will sit together, look at all the edge cases, look at all the occluded cases, look at ones that we felt that our quality was low. We actually record that. Look at where people had the most doubts or disagreed between teams, across teams. And they will actually iterate across that and actually be able to train people across that. Now, when the client gets involved with it, the clients also learn what of their algorithms have to be changed, why the algorithms are not working. Because remember, the millions of tasks that are happening is actually happening through our workforce, because that's who is annotating. So that retained learning across iterations, and I already talked about data security and the audit trail, having audit tools that actually go across and say, you know, you brought 10 new people on for this particular workflow, and all the quality was below 50% for the first week. So there is either something in the goal questions, there's something in the training. So having that audit trail, and why does it take one workforce faster to come on board and one workforce slower? All of this came through the team leads. So we're going in, so think about this. And they said something to me that has stayed in my mind that I will share with you. I don't want to be pretentious about it, but they talked about it is important as we move forward to look at it as building a mini Accenture for AI services. What does that consist of? The best trained contributors, good team leads, project managers, good process, ability to go in and look at each person's quality and throughput, looking at all the edge cases, having a knowledge system that iterates across, having the right processes, the right security, audit, and solution architects or architects who can bridge all of this together with the client. And that, and having certifications for people in annotation and validation of algorithms, as we go a lot into validating algorithms, this is the way in which this workforce is being built. This just gives you the increasing complexity of what we work with in computer vision. Average age of our workforce is 24. It's actually 24.1. And they will look at me and they will say, you know, we have 27, almost 2,800 people, and they will say, oh, if it wasn't for you, it would probably be 23. So this is it's a very born digital, born mobile workforce. 50% of our workforce are women, 51%. And in an AI, in a tech services company, I mean, 50% women is pretty rare, unique. And why? Is it because I'm women, female, I like to hire female? No, they do the darn best computer vision work. You have an image, and you have 90 bounding boxes to draw on that image. At pixel level accuracy, you can get that. So we have looked at different skills of different people and analyzed where the natural language processing comes in, where computer vision comes in, and who would be the best people. So you can say, is this a garbage man, a pedestrian, or part of a vehicle? Are you trying to avoid hitting people, or are you counting people? These are all things, judgments that need to come across. Good annotation design, you try. Robert talked about being together and annotation. This is what makes it interesting. You sit down and you try to put bounding boxes. People say bounding boxes, just give it to the tool and it will do it. Believe me, it can take up to 45 minutes to annotate something that's got bounding boxes. It's just bounding boxes, guys, go for it. Go annotate the bounding boxes here. Talked about the deep and narrow training of, and the docs and the videos when you're looking at medical imaging. Variety of different things. So when I come back to Roberts and look at this, start your data strategy with your algorithm strategy, completely agree. Training the algorithm is what produces very good algorithms. And the more respect you show people, I would say annotating and validating your data. Of course, if it's a professional workforce, why would you even ask the question, do we pay fairly? Of course you would pay them. Of course you would have the benefits. Of course you would have medical benefits. Of course you would have a creche for children that they might have. Security, to me, security comes along with that, but when I think security, I'm thinking SOC 2, ISO 27001, to be really honest about that. And providing the transparency, looking at them as an extension of your workforce. And that is what builds quality, stability, dependability, and a very, very dedicated, committed workforce. So I would say it then provides you an insight, very enterprise, and you can plan for long-term secure pipelines. And that is true whether you're a young company wanting to go public with your products or an enterprise workforce. So with that.
All right.